All right, this is your day 4 notes. So I'll write day 4 here. And it's over the rate of change. Rate of change is actually the average and instantaneous velocity. Now, let s of t be a position function. And we're talking about position function. We want to say the position of an object s in terms of time t. Over a period of time, I will say delta t, an object will change position by, the general formula is s of t plus delta t minus s of t is equal to the change in position, delta s, where, as I just said, delta s represents the change in position, delta t is the original time, or st is the original time, compared to t plus delta t is the position after time t. All right, imagine an object moving. Let's say here's an object and it's traveling, is getting to a certain position here. Let's go ahead and draw our x and y coordinate. The distance traveled, it will travel from here to here. Let's say it's doing this type of movement. Now, what exactly is delta? Let's see, it moves from this point to this point. So, if the original time, which is this one, is t, it means that this one is t plus delta t. Delta t being the distance in between these two. All right, average velocity. Let's look at the average velocity here. The average velocity, which is this blue line, will be the slope of the secant line. The slope of the secant line. Now, distance is equal to rate times time. You know this one. And we can therefore say the rate is equal to the distance over, actually the velocity is distance over rate. So r, which is the average velocity, and v is therefore delta s over delta t. This is t, by the way. The change in the position over the change in time. Well, delta s is actually what? It is s times t plus delta t minus s of t over delta t. Once again, this is the secant line. This whole thing is the secant line. Let's look at the first problem. It says a BR ball is dropped from 100 feet, and let s equals, or this equation represent the position of the ball at time t seconds. Here we're trying to find the average velocity over the specified time interval. This interval is from 1 to 2. So to find this, I will say s2 minus s1 over 2 minus 1. And this is like s2, which is this value, minus s1, which is this value, and 2 minus 1. I just plug in 2 into the equation, and I plug in 1 into the equation. You will end up with 36 minus 84 over 1, which is equal to negative 48 feet per second. This is feet per second. You will do the same thing for B and C. I think it's going to be a waste of time for me to go over this. But at the end, your answer for B will be negative 40 feet per second. And your answer for C will be negative 33 feet per second. If the velocity is negative, the object is just moving down. That doesn't mean that the velocity is actually negative. Instantaneous velocity means the average velocity over a small interval. So to find that, you need to also know that the tangent is actually the derivative. You should know this by now, because we've been working on this over and over again. Alright, I'm moving to the next page. As mentioned before, v of t is equal to x prime of t, meaning the derivative of the derivative of the position will give you the velocity, and the absolute value of the velocity is the speed, because the velocity involves the direction compared to speed is just the value. Now we have s of t is equal to 1/2 gt squared plus v naught t plus s naught. v0 or v naught is the initial velocity, s naught is the initial height. You're probably familiar to this based on your physics class if you took physics. The position of a diver t seconds after she leaves the diving board is given by this formula. When does the diver hit the water? To find when the diver hits the water is at t, you're looking for the s of t equals 0. So where the position is at 0? Well, on your calculator, you will use y1 is equal to 16 or negative 16t squared plus 16t plus 32. And y2, you will have 0. And you will look for the intersection. Well, I plugged that on my calculator, and here it is. And all I have to do is zoom 0, although you don't like zoom 0 as always. Zoom 0 will give me this equation. Now, my goal is to know what happened at t equals 0. So I believe even zoom 6 will have given me something nice enough. So I'm going back to zoom 6. Here's y equals 0. And there is the equation. Now, obviously, I'm not looking for the negative one because there's no negative in time. So I'll be looking for the positive value here. Second trace 5, enter, move it close to the one I want, enter, enter, and my answer is x equal 2. So it was after t equal 2 seconds. What is her velocity at time t? Well, this is actually the equation that they're looking for. The equation will therefore be, remember, vt is equal to s prime of t. By now you know how to derive this type of function. So to derive this one, it will give me negative 32t plus 16. And this is SV of t. The next question is, what is her velocity on impact? Now, velocity on impact means velocity on impact. This is instantaneous, by the way. So I will say negative 32t plus 16 is equal to 0. And if you solve this one, you will get t is equal to 0.5 seconds. What is her speed? Well, I just answered the question when. I answered the time. So this goes down here. Note that I'm saying this whole thing goes down here because I'm asking, I find t, which is the time. This time answer is from this one. Now let's go back to C. What is her velocity on impact? Well, it's impacting the ground at t equals 2. All I have to do is plug in 2. So if I plug in 2 into this equation, I will have negative 32 times 2 plus 16, which is equal to negative 48 feet per second. If you see a value that is negative, obviously it's the velocity. Compared to the absolute value of that negative 48 is 48, and this is the speed. And they're both in feet per second, by the way. We answered this question already because that was when. So last question is or last few questions. How high is she when her velocity equals 0? So we want, when the velocity is equal to 0, based on what we find out earlier, it is 0 at 0.5 seconds. How high is she? I would just go ahead and plug in that t equals 0.5 on my s equation, meaning s of 0.5 is equal to negative 16 times 0.5 squared plus, this is 5, 16 times 0.5 plus 32, which is equal to 36 feet. What is her average velocity over the time interval? Again, average velocity, that means I would do s of 1.5 minus s of 1 over 1.5 minus 1, which is equal to 20 minus 32 over 0.5, and your answer is negative 24 feet per second. At what time in the interval 1 to 1.5 is her average velocity equal to her instantaneous velocity? Well, I'm trying to figure out when negative 24 feet is the same thing as negative 32t plus 16. From here, you can solve it by hand. And if you solve this by hand, you will end up with t is equal to 1.25 seconds.